So to find the roots of polynomials, we're going to use the following steps. We're going to use the rational root theorem to list all possible rational roots. Then you're going to use your calculator to find one root and perform synthetic division on that one. So what that means is you're going to start with 1, and you're going to plug it in and see if it equals 0. If that doesn't, do -1, plug it in, see if it equals 0. And you do that until you find the first one that equals 0. And then you use that as your synthetic divisor, and you do synthetic division with it. Then you factor it, you rewrite the original equation in factored form and continue to solve the remaining parentheses equal to 0. If it's quadratic, you can stop and solve. But if it's not quadratic, like if it starts with a 4th degree and you do synthetic division, it'll bring it down to a 3rd degree, you would have to do synthetic division again. So you would have to go find another root, or sometimes the same root will work twice. We'll talk about all that as we go. But you would have to do synthetic division again to bring it down to quadratic. But as soon as it hits quadratic, you can set it equal to 0 and like factor and solve, or use the quadratic formula and solve. And we'll do an example of each type. In the end, you should get as many roots as your highest power, unless some have multiplicity of 2 or greater. And we'll look at one of those as well. And just to be clear, there are equations where all of the answers are in that list. And then there are equations where only one answer is in that original list. You have to show me your work, because I'm letting you use a calculator to find the first one. You have to at least show me a couple of the steps there. You can't just go plug them all in and be like, hey, I got all 3 of the answers, I'm done. You have to show the work, or I'll just take the calculator completely and make you do synthetic division on all of them, which wouldn't be fun at all, right? Okay, so here's our first example. We're going to find the roots of the polynomial p of x equals 2x cubed plus 3x squared minus 8x plus 3. So if we want to solve this polynomial, the first thing I need to do is set it equal to 0. And make a list of all of the possible rational roots. So we know that that will be plus or minus all the factors of the constant, which would be what? 1 and 3. Divided by all of the factors of the leading coefficient, which would just be 1 and 2. And then we need to split that up and actually look at them so we can see which ones we need to test to find that first 0. So that gives us plus or minus 1 over 1, 3 over 1, so 1 and 3, and 1 over 2 and 3 over 2. At this point, we're going to use our calculator. We're going to substitute positive 1 in and see if it makes this original equation equal to 0. And if that doesn't work, we're going to try -1. If that doesn't work, we're going to try 3. If that doesn't work, we're going to try -3. And if that doesn't work, we're going to try 1/2, and so on. So I'm going to pause right here and give you some time to find the first solution. So you guys said that positive 1 works, right?
Right.
Okay, we're going to use that as our R value for our synthetic division. So we're going to put positive 1 right here. We're going to use our coefficients, which are 2, 3, -8, and positive 3. We're going to perform synthetic division here. This will be a 2. This will be 5. Notice right here how I got the 0 remainder. If you don't get 0 there, one of 2 things has happened. You either picked the wrong number, or you did something wrong in your synthetic division. So if you don't get 0 there, you need to just stop and kind of start over. All right, this is the part where some people get confused. What this allows you to do, it tells us 2 things. It tells us, first off, that of my 3 answers, positive 1 is one of them, okay? It also tells me that when I divided by, what did I divide by here? I divided this polynomial by x plus 1 or x minus 1? X minus 1. And so it tells me that x minus 1 times this remaining thing here, which is going to be what? 2x to the second plus 5x minus 3. It tells me that this right here multiplied by this quadratic equals the original. In other words, we have factored it. Like, that's what synthetic division allows you to do. It allows you to factor something that you couldn't algebraically factor with any other method. So that's factored form. And we can tell from factored form that this answer is positive 1. Since this is a quadratic, we don't have to do synthetic division anymore. It will either factor on its own. You guys, I think, use bottoms up. Most of you, yeah. You could use bottoms up, or you could just like do trial and error if it will factor. If it won't factor, you'll have to use the quadratic formula. But I think this one factors. So x minus 1, and then we'll have these two. So this will be a 2x, this will be a 1x, a 3, a 1, a positive, and a negative. So just take a second and get that factored. Make sure you understand how it factors and why it factors. And then we'll be able to look and see the 3 solutions. So from there we can see our 3 factors, and we can see that x has to equal positive 1, positive 1/2, and negative 3. So those are our 3 solutions. And you should be able to check all of them by storing them and substituting them into the original. They should all 3 make it equal to 0, if you want to double check those. So here's our fourth example. We're going to find the zeros of the function f of x equals x cubed plus 7x squared plus 11x minus 3. So I'm going to give you a minute to see how far you can get. Start making a list of possible rational roots. Start substituting in and see if you can find the first number that will produce a 0. Okay, so we made a list, right? And we said that it's plus or minus 1 and 3 divided by just, this is an understood 1, so that's nice. So that's just plus or minus 1 and plus or minus 3. And then you guys tested those, and which one worked? Are you sure? Negative 3 works?
Yes.
Okay, so negative 3 is a 0, so we're going to do synthetic division with negative 3. So we have positive 1, positive 7, positive 11, and negative 3. We'll perform our synthetic division and write it in factored form. Okay? And that drops it down to quadratic, right? So make sure you understand how to write it in factored form. This will become an x plus 3 or an x minus 3. That will become an x plus 3, and this will become 1x squared plus 4x minus 1, and all of that will equal 0. So we took something that didn't look like it would factor, and we actually forced it to factor using the rational root theorem and synthetic division. Once you have it down to quadratic, even though that quadratic won't factor, you don't have to do synthetic division anymore. You can just what? Quadratic formula. Once it drops to quadratic, you just solve each one separately. So this one we know is negative 3. And this one we're going to perform the quadratic formula on. So we have x equals opposite b plus or minus square root b squared minus 4ac all over 2a. So would someone get me the discriminant, please? Whatever b squared minus 4ac is?
20.
Positive 20? Okay. All over 2 times a. Then you do have to clean that up as far as you can. So we have negative 4 plus or minus 2 square roots of 5 over 2. And that will simplify to negative 2 plus or minus 1 square root of 5 over 1, right? Or just negative 2 plus or minus square root of 5. Okay, so you can see the 3 answers. This is one of them, and these are the other 2. And then when you type your answers into WebAssign, you will have to take these apart. So we'll type them in as negative 3, comma negative 2 plus square root of 5, and negative 2 minus the square root of 5.